Hi everybody, this is Amit Kumar and I welcome to Qlik Solutions. In this tutorial, I'm going to give you step-by-step guidance on how to perform clustering in Qlik Administrative environment. So, what is the purpose of clustering? So, the purpose of clustering is to make a scalable and distribute service across nodes. So, clustering works in a multi-node environment. But a server, in a big server, right, in a data center, server size would be very huge, but they will create multiple small containers or multiple virtual machines. They will allocate the virtual machine to specific installations. In one VM, that would be Linux, another VM, there would be Windows, okay, like that. So, when you deploy the Qlik Sense Qlik View dashboard into the server, so QlikView has a QMC, the server which is shown. Qlik Sense is also having a Qlik Sense QMC. Okay, operations, features, absolutely same. So it is basically a deployment architecture, not development practice. So here, distribute service across the node. That means the application will be scalable. Scalable in the sense, like say, you you are going to deploy the dashboard in the cloud server, or in uh, on-premises server, okay, in your data center. Now maybe you are deploying the dashboard and their database in the Bangalore server, and the other server would be installed in Pune. Okay, so what is the benefit of this intra-geographic deployment? The benefit is scalability. And in case there is a problem in the Bangalore data center, maybe outage of the service, server would goes down. What if in that case your dashboard will get down? No. If you would have installed both the servers in the same data center, then there would have been a problem. But since your application are deployed across multiple nodes in multiple geographies, then if your Bangalore server and data center will be completely shut down, then your Pune server will also work. So cluster is something that's a group of multiple nodes. You know, a service is your service is ClickView dashboard. That is a service which will be deployed across multiple nodes, and all nodes will work in a cluster. If they will not work in a cluster, they will be working in silos. If your Bangalore server will be down, China server will not respond. Since they are cluster, one service will be deployed in your nearest server, and on a real-time basis, it will be automatically sync to the other cluster servers. Okay, clusters are acting just like your clones. You have to deploy the application 5 times in 5 different servers first. Then you have to configure all those servers behind a HA proxy. HA proxy means like one proxy engine should be there, that is called as a load balancer also. And technically this is also called as a load balancer. When request will be landed, it will land it to the HA proxy load balancer. It will see that Prakash is accessing the dashboard from Hyderabad and nearest location is Bangalore. Your request will be routed to Bangalore. Whenever you store anything, you change anything in that Bangalore server, it will be primarily stored in that Bangalore server. But other servers, since they are configured in a cluster, will be in real-time basis. The data, the changes will be synced to the other servers. All the cluster, services will be installed in multiple nodes, but central configurations will be there through the HA proxy, and high availability and resiliency. Now, what is the use of high availability? Means, as I said, in a one environment or one data center, if your server get down, in another environment, the server will be respond as a secondary server. See, here the user. Okay, here user is going to access to the dashboard. So this is your dashboard. See, if it is a single node environment, then you'll have only one dashboard here. QV server, and behind this QV server there is a database. This is a database. Now, as a user, you request to go to this Qlik server, and this will retrieve the data and show the dashboard from here. But in clustering environment, this will not work like this. Okay? Multi-nodes environment. Okay, server 2, server 3, server 1, and server. Okay, there will be multiple databases. One application server, one database server. So here this would be HA for high availability proxy. Okay, your request will go to this. Maybe your HA proxy and the URL is, let's say, maybe this is the URL ibm.qv.com. Now HA proxy will decide here there are, let's say, 100 users are accessing. Here 50 users are accessing. Here there is 300 users accessing to this server now at a particular time. HA proxy will have all these updates. It will send the request. Now, if it will see that this server is the nearest server and the load on this server is 500, only 50, so it is ideal. So your request will go to this particular server, and there are 3 different databases, and you will go to store the data into this server. Now, all this server has 500 records. If you have, if you are entering 2 more records, then 502, then this should also sync to other servers. Otherwise, next time when you access to this server 1, okay, click the server, this one, you have 500 server. So there should be a syncing between all 3 servers. Now this syncing will be done here in the database side. Clustering engine will configure and it will sync the data between all the databases on real-time basis. Just like views. In table you do any changes, it will be shown in views. In clustering is also does the same. If you do any changes here, 502, it is 502, 502. If there will be entry here 522, then it will be immediately 522 in all the servers. So this is how the HA proxy and clustering environment work. And the outcome is, first thing is service performance optimization. If you have, you know, 450 users, then all 450 users would have landed on a single server without HA proxy. Then the load on the server must have high and the server would respond less. Now if you have multiple nodes and you have distributed the load from the HA proxy, it will first land in the HA proxy. HA proxy in HA proxy, the algorithm will be written to diverse the load to the optimal use server. So server will get and distribute the request, and request will be segregated. And sometimes we do it in a single cloud platform or single server data center. Sometimes we also do in a intra-geographical servers. Performance will be optimized here. High availability and resiliency will be ensured. Server would never be down. If one server goes down, other 2 servers are available. Okay, this is the main purpose of clustering. And now coming to the step to configure the clustering. Okay, you have to first plan the architecture, nodes and roles and network. Okay, how many nodes would be there? You have to first create the VMs. If you have installation, then you need to have 3 application VMs, 3 database VMs, as is shown here. 3 application VMs, right? It may be a Linux server, it may be Windows server, 3 database VMs, right? Maybe SQL server, multiple instances. So prepare server, DNS, ports, and network adapters. So multiple servers, multiple SQL server instances will be installed in these 3 servers. You have to repeatedly deploy the Qlik dashboards to these 3 servers. Okay. First you deploy here, then after completion of here, you have to deploy here. So individually, without accessing to HA proxy also, you can access to the three servers. Let's say the server IP address is now I have three application servers. Each application server, they all access through IP address. There's one IP address, another two, second IP address, and third IP address. 10, 11, and 12. Okay, three servers I have. HA proxy has also a public IP address. This is basically private IP address, and this is public IP address. Public IP address will be accessed from the external outside of the data center. And these all IP addresses are private IP addresses which will be accessed inside the data center. HA proxy will have a public IP address. Okay, individual all three server has to be tested, right? Then after testing and ensuring that all three servers are independently also working, you have to configure HA proxy. In the HA proxy, you have a property to add multiple nodes. Okay, to add multiple nodes in the HA proxy. So there, in the proxy server, you have to configure all the servers, VMs. You have to add the addresses of these VMs and create the algorithm for primary, secondary, tertiary. Okay, and then it will route to the respective servers. You can also monitor that which server is responding, which server is not responding, where there is a request is going. Let's say request is going to only 10 and 11, not going to 12, then this does thread. You have to also check what is the problem with the HA proxy and the individual VMs. Now prepare servers, right? OS. This OS, Windows OS, all three servers you have to prepare. And nodes you have to prepare. Port number, let's say installation of this server, you have to install, and port number you have to define 8801, 8802, like that. And then install central node, and HA proxy is central node. Okay. And configure service cluster in QMC. So in all the servers are installed. Okay, individual servers are installed. You got their individual IP addresses. Now you have to go to the QMC, which is a admin environment of Qlik. There you have to configure HA proxy. Simple configuration you have to do in the QMC environment. This is already have installed. Installed a Ream nodes. Join Ream nodes in QMC nodes, and authorize nodes certificate and configure proxy node balancer. Authorize nodes certificate. So basically individual nodes will have few licenses and individual certificates. Okay, configure proxy and load balances. Step 2. Then coming to step 3, and verify services, reload and routing. What I told, verify services in individual servers. You have to individually call this database servers, whether this database, you have to individually ping in the data center, ping DB1, DB2, DB3. Verify services, reload and route services. Reload and routing. And perform monitoring, backup and handling. And document roles and maintenance plan. So similar quick checklist. These all things has to be configured before you mount to the HA proxy. Architecture has to define, which we done. Domain name services. Okay, DNS. As I told here, what is our DNS? ibm.qv.com. Qlik views. Because IP address you cannot remember every time. Architecture plan, sizing plan. Then DNS is purchase of domain name. Central node install means HA proxy install. The Ream node added and authorized. Ream node means what? All three Ream nodes, right? This is central node, HA proxy, and these are Ream nodes. The more performance you want more speed of the dashboard, you can add more nodes also later on. So Ream node added and authorized. This has to be authorized from the central node which is installed. Then proxy has to be configured over there. This architecture is a client load balancer, which is I've already drawn, right? Okay. And a load balancer, and this is the central node, which is a server where Qlik repository would be there, QMC, Qlik management console, scheduler, and central engine should be installed. And failover cluster, which is optional, means in a data center you have kept one copy. In cloud you have kept one another copy, which would be in separate locations. So storage would be in the cloud. So this is optional this part. But if you go with our central node and proxy node, then here we have repository, proxy. It has also a database which keeps all these informations like repository Postgre database, or external database, and backups, and high availability. So this particular part is belongs to this central node. Okay. Now behind the central node, you have engines, worker nodes. Those are ream nodes. Okay. Ream nodes in node one. Servers, yes. So Ream 1, Ream 2, Ream 3, this is servers. So individual application repository should be there, database repository should be there. So this is the major approach of the HFX. Component, port, uh, load balancing, these are all the services you have to ensure there. The recommended roles and sizing guidance. Okay, in central node, at least 8 core CPU. Okay, vCPU means virtual CPU, and 32 GB RAM. It should be there. Okay, and in the engine nodes also called as ream nodes, and engine nodes, ream nodes, you require minimum 4 to 8 core vCPU and 16 to 32 GB RAM each server. Each server should have absolutely identical sizing and storage, fast SSD performance. So these are basically required. Uh, Proxy server administration. See here, nodes in Qlik Sense. Host name, which is a DNS. Okay, DNS server. And there you have to go through these ports. You have to mention the port number, and this DNS is a central DNS, which is a proxy. Okay, and virtual proxies, right? Virtual proxy, you can add new server nodes. You can add multiple servers by clicking plus 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 here. Okay, and then uh, this is you see here, this is central node is showing here, and node to the other nodes like ream nodes. It's also showing here. And that concludes this video. Thanks for watching. See you in the next video. Till then, bye bye.